Hey guys, welcome to my channel, or welcome back if you have watched other of my videos. This is my third video about LED cables, and I think the last one. Then I think I analyzed enough to have a feeling what to consider if you use them, and that we have a good impression what the impact can be. And first of all, a short recap, because in the last video I didn't show unipolar and bipolar. I will do that, but I try to keep it short, hopefully successfully. And after that we will do the audio test, which means one channel with normal patch cable, one channel with an LED cable, hard panned left and right. So you can compare the audio if you hear differences with an analog oscillator and a digital oscillator. I'm not sure if it makes a difference, but we'll see. And first of all, just a recap about bipolar and the voltage drop. So you see here, oh, I'm not sure if you see it. I connected the octa source again in bipolar mode to a mult, and the left channel is normal patch cable, right channel is LED cable. You see it flashing here and you see it alternating. In this case, red means positive and blue is negative. You see it here. I got it in the quad scope for later on for the audio test to see the note, the tune. And then it's connected to the oscilloscope, which I'm zooming in a bit. Okay, we see that before. This is a normal bipolar LFO wave, a simple wave, and you see here bipolar means you have positive and negative in kind of in regard of voltage. Positive voltage is here at the top, and at the bottom is the negative minus. In the middle is 0 volt. And you see, I'm just freezing that, you see on the one hand we have measured here 10 volts roughly for the normal patch cable and 9.297 volt for the LED version, which means we have a voltage drop of roughly 0.7 volt or 700 millivolt. Yeah, this should be, I think, yeah, acceptable, but it's lower as we knew before. And same again, in the middle we have no difference in the waveform because the LED starts flashing at the top and bottom, and in the middle they are not on, which means they do not draw current and do not drop the voltage, which means the waveform in the middle roughly or around 0 volt is the same with patch cable, normal one or LED one. And as soon as the voltage rises in the positive area or drops in the negative, you see the difference here. So this is bipolar. Now we switch to a unipolar waveform, just to let you see this. I think it's clear what happens, but I'm a fan of showing it or seeing it myself. So we're just shifting it. Okay, before I shift it, sorry, I have no script. I'm doing this as what's coming into my mind. So this is unipolar, and this means the bottom here is 0 volt, and you have only positive voltage. I'm just shifting it down a bit. If I increase the voltage, we can see it better. But the minimum value here is 0 volts, and it can go up to whatever it can generate. So I'm using the Sadar here, which is a nice module for really cool envelopes. And additionally, you can speed it up, modulate it, whatever. But additionally, you can here with this knob, you can change the voltage. You see in the display here how many volts I'm putting out, or the module puts out, and that's cool. We see here, now I have a very simple form, and the voltage is, let's reduce it a bit. So let's see, the module shows 5 volt now, and here we have, yeah, it's really exact. It's okay. So here we have 5.2 volts with a normal, 5.1 with a normal patch cable, and 4.7, 5.1 on the left, and 4.7 on the right with the LED cable. So we see we have the drop, and the LED is lighting here on the right. And we will see, I think, when I increase the voltage, the Sadar can deliver up to 10 volts. We should see voltage drop that is getting higher. Yeah, we see it already. Okay, I put it up to 10 volts maximum. Okay, and this is interesting. Now we have, with the normal version, 9.5 alternating a bit volts, 9.4, 9.5, yeah. And on the LED version, we have 8.3, and this is a big drop. And here we see that, just stop it here, we see that it's really clipping with the LED cable. So, okay, it's up to 10 volt, so I'm not sure if you use this high voltages in envelopes, but with the bipolar, I think we have also a 10 volts range, but plus 5 to minus 5, so it's not so high on the one end. And here we see the first time that the LED waveform really clips and cuts off the peak. Okay. If I reduce, but as we know on the bottom, which is 0 volt, and rising, it's okay, but as soon as we come near to the peaks, I'm reducing the voltage. Let's see, now we are at roughly 9 volts. Let's see. Yeah, you can say 9 volt, it's okay. As soon as we pass 9 volt, it starts clipping. Okay, we are back to 6. Yeah, here we don't see such a big change. Okay, but we've proven that the LED cables can clip as soon as you have high voltages, which means it will not rise above this 8 point, let's see what it was, 8.2 or 3 volts. In my opinion, you cannot put higher voltages through, so not through the flux noise cables I have. So this is important to understand. Okay, now I will just repatch something, and then we do the audio test with the analog and digital oscillator, and because I will not talk then, I will write it in the description, and perhaps in the video we'll see. So the left channel you hear, it's hard panned, so it's a stereo signal, and the left channel is like it's patched here everywhere. The left channel is the normal patch cable, And the right channel will be with the one with the LED cable, and we will put different signals through, and let's see if we hear something. I will do it on a, as I mentioned before, on an analog oscillator with different waveforms, and starting from C1 up to C6. So if you have headphones on, be careful, C6 is a high note. Or if you have speakers or whatever, but be aware that this is a high frequency for your ears. And with the digital oscillator, the same. I will have different waveforms and also C1 to C6. And I will try to create chapters where you see the notes and you can jump whatever you want to hear. And feel free to comment if you hear something, if you hear differences. And I think this was my last video. If you have any questions rising of these topics here, or additional questions about these cables, or something which would be interesting to measure and to analyze, feel free to put it in a comment. But yes, for me, I think I learned enough to know for what I use them. As I said in the last video, it's good for triggers, in my opinion, and for the LFOs to see if they're unipolar, bipolar, how fast and whatever. It's good, but be aware that the signal is weaker. And if you use it for envelopes, we learned today, especially if you have high voltage envelopes, which go up to 10 volts, they will be clipped a bit. I'm not sure if it's relevant for you, but it's good to know. Okay, now I will repatch and we're doing the test. Thank you. So we did the test and I will not do the test with a digital oscillator because while recording this with my headphones, which are quite okay, I think, I did not hear any difference. So I think it's not necessary to do the test also with a digital oscillator. I think it makes no real difference. But if you hear something, feel free to comment, and then perhaps I think about doing the same with a digital oscillator. But right now, from what I'm hearing it is not necessary because I did not really hear something. So thanks for watching, thanks for listening. If you have questions, as I mentioned before, feel free to put it down in the comments. If you have feedback, also have a good time, patch on, have a good time, and do great stuff with your modules, and patch on. Bye bye.